Okay, hello. So I am going to do my best to explain this atmospheric pressure, intrapulmonary pressure, intrapleural pressure, intrapulmonary volume, and transpulmonary pressure to you guys, because in our study session today, we did not do a good job explaining this. This is a really huge concept, so this video will probably be like 10 minutes plus. So I'm going to try to do this as quick and thoroughly as possible. So if you have any questions at the end of this, then please ask me a question, because I just want everybody to understand this, because it's a big concept and I'm sure it's going to be on the test. Okay. Oh, okay. So let's start by defining all of our terms right now. Okay. So atmospheric pressure. This is a big one, okay? Because in the study guide, Dr. Mathia is asking how this atmospheric pressure relates to breathing in, the pressure in our lungs when we breathe in, and when we expire, when we breathe out. So let me first say, atmospheric pressure is always going to be 760 millimeters of mercury, okay? Atmospheric pressure is the pressure around us, just like outside of your body. And due to the fact that the respiratory system is an open system, meaning that there's like nothing that has our system blocked off, because, I mean, when we just breathe in air, it goes directly down our respiratory organs into our lungs, right? Easy. So that means that the atmospheric pressure needs to be at equilibrium with the pressure inside the lungs, like as much as possible. And so pretty much this whole concept is in relation to the atmospheric pressure, okay? So our next terms, we're going to talk about intrapulmonary volume, intrapulmonary pressure, intrapleural pressure, and transpulmonary pressure. So while I was saying that, I brought up this picture from our slides, slide number 61, if you would like to follow along on your own slides. So intrapulmonary pressure. So intrapulmonary. So think intra, inside, and pulmonary. We know pulmonary from the circulatory system. Pulmonary means lungs. So inside the lung pressure, this pink part right here. Notice that the intrapulmonary pressure says that the pressure is 760 millimeters of mercury. What did we just talk about that is also 760 millimeters of mercury? Boom, atmospheric pressure, because it has to try to remain a constant equilibrium because it's an open system. Okay, and also think 0 for this in terms of our graph in relation to atmospheric pressure with breathing in and breathing out, inspiring and expiring, because you're going to have to understand that 760 means 0 in relation to it when we refer to our graph after I explain the terms. Okay, so next, intrapleural pressure. So intra, again, inside, and pleural pressure. So we've talked about this term pleural in Anatomy 1 when we talked about the membrane, the visceral and parietal pleura that protect the lungs. So the pressure within this needs to be -4 in comparison, because of the fact that if these two are equal, the intrapleural pressure and the intrapulmonary pressure, if they're equal, that's going to end up with a collapsed lung. And so how these relate to each other, intrapleural pressure and intrapulmonary pressure, is right here, transpulmonary pressure. And so you can see the numbers right here, 760, which is intrapulmonary, minus 756, which is intrapleural pressure, equals 4. So just remember, transpulmonary pressure always has to remain a constant 4 millimeters of mercury difference, because if that is not a constant, then your lungs will collapse. So moving on. So yeah, we've defined all of our terms. Okay, so this and how it all relates to inspiring and expiring. So breathe in, breathe out. Okay. So we're going to start off by talking about intrapulmonary volume and intrapulmonary pressure and how they relate to each other. Okay, so If you remember, we talked about Boyle's law, and that's pretty much stating that volume and pressure have an indirect correlation to them. So if intrapulmonary volume is up, then intrapulmonary pressure needs to be down, and vice versa. Look at over here. When you expire, intrapulmonary volume down, intrapulmonary pressure needs to be up. So if one's up, the other has to be down, okay? So always remember that. That is just Boyle's law. That is just the law. So that is just how it always is. And notice down here, though, intrapleural pressure is down in comparison to intrapulmonary pressure being down. When you inspire, breathe in, and intrapleural pressure is up while intrapulmonary pressure is up when you expire. So think about that for a second. Why do you think that these have a direct correlation to each other as compared to the volume and pressure having an indirect? So when we look back over to our picture right here, intrapleural pressure and intrapulmonary pressure. Remember this, transpulmonary pressure. You can't have one of these numbers going up while the other is going down to maintain 4 millimeters of mercury. So for that reason, if intrapulmonary pressure, for example, is going to be increasing, intrapleural pressure has to also be increasing to be able to maintain this 4 millimeters of mercury, or your transpulmonary pressure. So let me give you an idea. This right here is intrapulmonary pressure, this line right here, and this right here is intrapleural pressure. Notice this line right here is indicating transpulmonary pressure and how the difference is 4 millimeters of mercury. See, if the pressure is going down, this pressure has to also go down, because you know what? If intrapulmonary pressure is going down and intrapleural pressure is going up, see how these meet each other right here, and you're not maintaining your transpulmonary pressure of 4 millimeters of mercury? That's going to end up in a lung collapse, and that is going to be considered pneumothorax. And you're going to want to remember pneumothorax because that was in the book, and I'm sure that's going to be on the test. So when you see volume and pressure, inverse relationship. Lung pressure and the pleural pressure, direct relationship. One's down, the other one has to be down. So let's talk more specifically about when we inspire. So when we're inspired, breathing in, the intrapulmonary volume, so the inside of our lung volume is going to increase because there's a bunch of air in our lungs. So because of the inverse relationship, that means that the intrapulmonary pressure is going down. So let's put that into numbers in relation to atmospheric pressure. So remember, atmospheric pressure is 760 millimeters of mercury, and intrapulmonary pressure is also 760 millimeters of mercury at equilibrium because of the fact we have an open system and it has to remain as constant as possible. But when we are inspiring, our pressure is going down. And so what does down pressure mean? That means you're subtracting 1 millimeter of mercury from the constant 760 millimeters of mercury, which is the same as the atmospheric pressure. So when you're inspiring and your pressure is going down, that's going to result in 759 millimeters of mercury. So we're going to take that over here to our little chart. See how I have -1 right there when you're inspiring? I have -1 right there in relation to the constant 760 millimeters of mercury. So when you're inspiring, it's going down. The pressure of the intrapulmonary pressure is going down. And it isn't until you've reached your climax of inspiring, like right there where I have to expire, that pressure is going to go ahead and equalize again with atmospheric pressure at 760, and it is going to go back to 0 right here. So we'll show you on this graph as well. We are inspiring in relation to the atmospheric pressure, so think of 0 as 760 millimeters of mercury. we're inspiring, it's going down because the pressure is going down while the volume's going up. And it isn't until we've hit like right before we have to expire that it equalizes in pressure, because like I said, open system, we have to try to remain atmospheric pressure 760 millimeters of mercury as much as possible. Okay, and so then that is going to take us into our expiring. So since we have gone 760 millimeters of mercury minus 1 from inspiring to 759, we've hit our climax, so we've reached right back to 760 or 0 right before we are going to expire. So right before we are going to expire, we're at 0. We're going to go ahead and go up 1 millimeter of mercury. Why is that? When we are expiring, all the volume is out. So what does that mean? Intrapulmonary pressure has to go up. So we're going to be doing our atmospheric pressure, 760, and we're going to be adding 1 millimeter of mercury because the pressure is increasing while the volume is decreasing because of the inverse relationship. So we're going to end up with 761 millimeters of mercury. And it isn't until you have reached your, okay, so we're at 1 right here. It isn't until you have completed your expiration and you've gotten back down to 0, aka 760 millimeters of mercury, because it's relating to the atmospheric pressure, that you're going to get back to atmospheric pressure. Okay, so look at this line. This line right here specifically, intrapulmonary pressure. You are you are inspiring, okay, -1. You've hit your climax of inspiring, you're about to expire, but you get back to 0, 760, because it's an open system. We have to remain equilibrium as constant as possible. And so then you get to your expiring, the pressure goes up because the volume is going down while you're expiring out all the air. And then you get back down to 0 again, aka 760 millimeters of mercury, because this is just a constant little wave thing where pressure going down because we're inspiring, pressure going up 1 millimeter mercury because we're expiring. Okay, I think I've explained everything. If for some reason I did not explain anything, you could rewatch this video while looking at this chart. Even just looking at this chart, see volume of breath, okay? Intrapulmonary volume. Volume going up during inspiration, pressure, both these are going down. Volume going down, pressure of both of these during expiration going up, up, up. And remember again, what happens if you don't maintain your transpulmonary pressure? Your lung will collapse, okay? And why is that? Imagine you have your lung right here, okay? And you're letting in a bunch of volume while you're inspiring, when you're breathing in. It's going to push out on this intrapleural space. It's going to try to expand. And the thing that lets us do that is our ribs. Our ribs expand to let in the volume of air. If it did not do that, then the intrapleural pressure would not be able to maintain the transpulmonary pressure of 4 millimeters of mercury, and our lung would collapse. So the reason why we are able to maintain transpulmonary pressure and not have a collapsed lung is because our external, external intercostals are able to expand. I think this is the right picture. They're able to expand while air and volume comes in. And if that was not able to happen, just imagine like your ribs not being able to move. This would try to fill up the space. It's going to pop because, it can't go anywhere, and then you're going to end up with a collapsed lung. So I hope this explained everything. If you have any questions, then please let me know, but I hope this helped. Okay, goodbye.